It's an Ans Key Vid coming to you live from the space. So let's go off 10.06. What we're working with mainly is that was all right. Okay, can you erase that, please? Little V equals IR, right? This being Ohm's law. A reminder that V stands for voltage measured in volts, I stands for current measured in amps, and R stands for resistance measured in ohms. And now what we're going to do is basically look at the circuit, and we want to figure out some things. Now, really interesting thing that you could have done is anything stop you from building this applet or building the circuit in the app? And you could have just like messed around and tried to figure out like what value of R3 would give you that 2 amps. That would be one way to do it, but let's figure out the other way to do it. Now, so the current through R2. So the second resistor, we're going to know what's the current. Well, I know that the total current in the circuit is 2 amps. So this answer is going to be 2 amps. The reason is there's only one singular path for those electrons. So any electron that's going to come here is going to go through R1, R2, R3, and then back. There's not multiple paths. So because there's not multiple paths, there's only one path. So they're going to have to all go through that. We now want to determine the voltage across the 4 ohm resistor. So by the same regard, that means that the current right here is got to be 2 amps, and the current here is 2 amps, and the current here is 2 amps, and over here it's 2 amps. It doesn't matter where we're looking, the current's always going to be 2 amps. So if I look for voltage, current voltage is current times resistance, Ohm's law. Now the one thing that I like about Ohm's law is subscripts matter. So if we're looking at the 4 ohm resistor, that's R1. So this is going to be V1. I1 and R1. So V1 is what I want, and I1, well, how much current did we just say was at that resistor? We said that was actually 2 amps. And we know that the resistance of that is 4 ohms. Weird symbol there, right? 2 times 4, so then that means this is 8 volts. A little check for us. These resistors should, at a maximum, can use 24, but should be less because that's all the energy in the circuit is 24. So if this one, if I got, for instance, like 80, because I did my math wrong or something weird, that's way too much. Now, if we want the voltage across the 6 ohm resistor, so again, this is V equals IR, but this would be V2, I2, R2, right? So same thing again, we're going to have the current of 2 amps, but now this is actually 6 ohms. 6 times 2, last time I checked, was actually 12 volts. Awesome. Now we want to find the voltage across R3. It's some really important circuit rules. And one of them is really based off of something called conservation of energy, which I'm sure you're familiar with. If you have energy, you can't lose it. So we're talking about the total amount of energy or voltage in our circuit being 24 volts. So if the total is 24 volts, then that means the energy lost in this resistor plus this resistor plus that resistor has to be equal to the total. So if I'm going to write this out algebraically, I could write this as like the total volt. Whoa, sorry, that's weird. The total voltage would have to be equal to the first plus the second plus the third, right? Now I know 2 of these, and I don't know the third one, so we could think about as like the third voltage being the total minus the first minus the second. So we know that that first one is 24 volts. That's the total. Minus 8 volts minus 12 volts. And if we do this math appropriately, we should end up with 4 volts in the end. Cool. Great. And again, because we're getting 8 plus 12 plus 4, that's my total energy. I'm not losing or gaining any energy in the circuit. Now it says calculate the resistance. Well, again, V equals IR, and so we're talking about R3, be I3 and V3. So if I had a little algebraic, moving around, R3 would actually be V3 divided by I3, right? Do I have V3? Yep, just found it. Do I have I3? Yep, it's 2 amps because it's 2 amps everywhere. So this is going to be 4 volts divided by my 2 amps. So this ends up being 2 ohms. Boom shakalaka. Now what I actually like to do with most of these circuits is I make something called a Vert chart. So VIR. What you basically do is you make a row for each circuit element. So this is 1, 2, 3, and then 1 for the total. The reason I like this is it helps me keep everything a little bit organized in terms of my circuits. For instance, with this circuit, I knew that this is 2 amps, and this is 2 amps, and this is 2 amps, and this is 2 amps, so sort of just all fills in. The other reason I really like this this chart is V equals I times R. So like, you know, if we go back to the original question for a minute, we knew that this was 4 ohms, and we knew that this was 6 ohms. So if I just wanted to do some quick math, right, 2 times 4 is 8 volts, and 2 times 6 is 12 volts. And then we knew that this was 24, right? We knew that 24 volts, right? So then if I look here, well, this plus this plus this has to be equal to the total. So that would be my 4 volt value there. An organizational technique that I realized my head was in front of for part of this video. Great, awesome, way to go. But yeah, more complicated circuits seems to be a bit more helpful. Let's head to the second question. So it says I have 2 resistors connected to a battery, and I don't know what the battery is. Unknown voltage, and we're trying to figure out which one has a bigger drop. Well, let's do this. Let's do. I don't like that pen. Let's do this one. E equals IR, right? I know that both of these have to have the same current because they're connected in a single path between them. So they have to have the same current. So because they have to have the same current, if we think about that, then that means voltage and resistance, if we look at this equation, have to be directly proportional. Now, let's think that does that make sense. If the resistance is bigger, that means it's more difficult for the electrons to get through. If something's more difficult, it's going to require more energy of us. So I think, you know, logically that's going to make some sense. So from here, if we want to know which resistor has the biggest voltage, it is without a doubt going to be the 15. And like simple justification, I don't know what I write on the key. The answer key says both must have the same current because they are connected by one path. Since current is the same, and we know Ohm's law, V equals IR, larger R will require a larger voltage. How nice! What a nice thing that I wrote. But yeah, that's what we got going on there. So these charts can be pretty helpful in solving circuits. We don't do anything too crazy, too complex, but they might help us organize our thoughts a little bit and everything that's going on. Hope this was helpful, and if not, check the PDF key and or send me an email. And until next time, thanks for watching.